So here's AISpace. I'm going to go to the graph tool. And we'll start the graph tool. I will tell it, really, it's okay. Yes, I understand. I don't really want to do it later. Honest to gosh, I want to run this. Here we go. Okay. All right. So what I'm going to do is I'm going to use the Vancouver neighborhood. So we're going to do best first. And we're going to do Vancouver neighborhood. So let's file, open, load sample problem, Vancouver neighborhood. And now we know why it says neighbor with an OU, because it's in Canada. And I want to make sure that view has show edge costs. There we go. And I'm also now in view, I can turn on the node heuristics. Okay. Remember, a heuristic is associated with a node, right? So, so let's go to the tool and let's see what happens here. So we started out, and as usual, we are starting at our start state, and our path cost so far is 0, right? The frontier just has one path on it, which is start here and do nothing. Can you see these numbers down here? Where is it?
I see them.
Where's the view? Font size, large. There we go. Okay. And the thing is, now that you look at these, at the heuristics here, you can see the heuristic for the goal is 0. That kind of makes sense to me. And as we get to locations closer on the map, the heuristic is smaller, right? Which hints to me that maybe this is a map that is not really drawn particularly well to scale, but still could be, let's just pull these guys down a little bit so we have a little bit more room. But maybe it is, in fact, an admissible heuristic, because if you look, if you get all the way out to SRY here, you're pretty far out, right? And the distances reflect that with this 21 and 22. Everybody understand the notation here, what's going on here in the picture? All right. So if I try to solve this, of course, I take UBC off of the frontier. I find its neighbors, that would be JB and KD, right? And I'm going to put them back onto my frontier in order of heuristic, right? Because it is a priority queue. So UBC to JB comes first because the heuristic of JB is 3, and it tells you that down here. UBC to KD, the heuristic is 6.0. Ignore these F values for a minute. We'll get into them in a minute, but path cost for both of these is 3, right? Before, on lowest cost first, they were even in terms of who got put on first, but because we have a priority queue based on the heuristic, JB is now our buddy, right? So I'm going to take a find step. Oops. So we're going to take a find step again, and we'll take JB off of the frontier. JB, it looks like, only has one neighbor, so that's not very interesting. Notice that JB is going to be, it's going to take us 7 steps to get to KB, but all we really care about for this algorithm is what is KB's heuristic, which is 3. So this UBC to JB to KB is going to be a nice progression that is going to be have a smaller value, which means higher priority on our priority queue. So when I take a find step, we've got the neighbors of JB. And so we end up with, even though the path cost is much higher, which is what we were concerned about before, UBC to JB to KB ends up at the top of our priority queue because the cost there is just 3, right? Okay, and so we can take another step, and we pull KB off the frontier. KB has one neighbor, which is DT. And when we put stuff back onto the frontier, we're going to put this big long path first because DT has 2 as its heuristic, right? Oh, and I forgot. Whoa, what happened here? Oh, yeah. So KB also has BBY as a neighbor, but that has a heuristic of 8, right? And so we end up with these 3 paths on the frontier in this order. Make sense? I'm staring at you guys now. That means if I'm looking off to the side here, I'm looking at you and you are all like nodding furiously. Okay, good. All right. So we take our final step. You know what's going to happen. We only have 1 neighbor. We grab it. Oh, it's not the final step, right? We've got the goal, but we have to put it onto the frontier first, right? So we add that to the frontier. But maybe when I said you know what's going to happen, it was because you knew the frontier has a heuristic of 0. So now it's at the top, and we take a fine step. We pull it off, and we found it. Okay, so that's pretty good. The thing is, as you might imagine, if you have greedy best first search and you are using a heuristic that is an admissible heuristic, you are likely to have good results.